Hello guys, how are you today? I hope everyone's doing well. I'll try my best to explain this video as good as possible. Also, sorry for my voice is not clear because I'm charging my tablet at the same time. So let's start. A monochromatic light source of wavelength 520 nanometers. We directly change it from nanometers into what? Into meters. So 520 times 10 to the power of minus 9 meters is directed at the diffraction grating of length to 1 centimeter. Always change it into meters. So 1 divided by 100 meters. That has 500 slits. This is n, the number of slits. If they want the slit separation d, in the diffraction grating to the nearest integer. If they want the slit separation d, we will follow an equation, which is what? Which is the length, okay? Which is usually 1 over what? Over n, the number of slits. And always remember it's in meters on top. So 1 divided by 100 over 500, we will get d to be what? We will get d to be 2 times 10 to the power of minus 5. So now we have what? We have the value of d, which is 2 times 10 to the power of minus 5. You need to change it into micrometers, so I will leave that for you guys to change it. Now, next thing. The angle being theta with the horizontal at which the sixth bright fringe, meaning that m is equal to 6, is observed to 1 decimal place. So they want to find what angle theta when m is 6. What do we also have? We also have lambda wavelength, and we also have d. So look, we have d over here. We have lambda over here. We have m. We have all the tools in order for us to find theta. What's the equation? The equation is d sine theta equals m lambda. So d sine theta, substitute d by 20 micrometer or 20 times 10 to the power of minus 6 times sine theta is equal to m, which is 6 times 520 times 10 to the power of minus 9. Now, after solving, I'm gonna leave that for you guys. So sine inverse of 6 times 520 times 10 to the power of minus 9 over 20 times 10 to the power of minus 6. This will yield us an answer which is approximately equal to what? Equal to 9 degrees. So 20 degrees and 20 micrometers and 9 degrees. Which two of the following statements are correct? All light passing through the gratings is coherent. Very true. Dark fringes are due to diffraction. They are due to destructive interference. Light passing through diffraction grating slows down. Not at all. It does not slow down. The bright fringes that are observed on the screen are due to the interference of light that's through its constructive interference. So this one and this one are the correct answers. Let's move on to question number 2. What does it say? It says, to investigate the properties of light, a group of scientists conduct a double-slit experiment in the lab. These slits are separated by a distance of how much of this? This means that this is small d, so it's 0.04 times 10 to the power of minus 3 meters, right? You always change it into meters. Then a screen is placed how many meters away? This is capital D from the slits. A monochromatic and coherent light source is used to produce an interference pattern on the screen. The fifth order, meaning that m is equal to 5, bright fringe is observed at a distance of 4.8 centimeter. This is x. So x, or not x, sorry. It's not good to use x because the equation is y equals m lambda d over small d. So y is how much? It's 4.8 centimeter times 10 to the power of minus 2 meters. Alright, perfect. Let's see what they want from us. I don't think we can see in this, but now that we have all of the information, please have them remembered. They told us they want what? They want the angle between the fifth bright fringe and the central axis to 1 decimal place. So where's the central axis? I believe the central axis is over here. And the fifth bright fringe would be, let's say, over here, right? They want what? They want the angle, this angle over here, theta, made between the fifth bright fringe and the central axis. So what can we see? It's a right triangle, right? And this over here is determined by what? This is the y. And this over here is determined by what? This is determined by d, because this is the capital D. So y is the position, okay, between two bright fringes or more maybe. And then d is the distance of the slits to the screen. So if we want to find the value of theta, this is what? This is a right triangle. So we can do opposite over adjacent, and that based on the SOHCAHTOA rule. is what is tangent. So tangent theta is equal to y over d, opposite over adjacent. So if you remember from before, what did we have y to be? Y was 4.8 times 10 to the power of minus 2 over what? Over d, which is 0.6. And don't forget to do tan inverse. So tan inverse 4.8 times 10 to the power of minus 2 over 0.6 is equal to what? Is equal to theta. So this should yield us an answer which is approximately 4.6 degrees, okay? We'll move on to the next one, which is the wavelength of the y. They want us to find the wavelength of the light used in the experiment. We know that we have what? We have small d. How much is small d? It's 0.04 times 10 to the power of minus 3 meters. We also have what? We also have m, which is 5. And we need to find what? We need to find the wavelength. We also now found what? We also found theta. So we can use this equation. D sine theta equals m lambda. So 0.04 times 10 to the power of minus 3 times sine 4.6 is equal to 5 times lambda. What is lambda? Lambda is what we need to find. Okay, so lambda in this scenario is equal to 0.04 times 10 to the power of minus 3, okay, times sine 4.6 over what? Over 5, and we will get the value of lambda to be approximately, of course, rounded and changed into nanometers, approximately 641.6 nanometers. So 641.6 nanometers. We'll move on to question number 3. What does it say in question number 3? In a Young's double-slit experiment, the following pattern of the light and dark fringes is obtained. The distance between the two, I think they mean 4 bright fringes. It's a mistake. The 4 bright fringes is indicated below and is equal to 5.4 millimeters. Now, the spacing between consecutive bright fringes to one decimal place. Okay, they want the spacing between from this bright fringe to this bright fringe. Very simply, what you're going to do is you're going to take the value of the length, which is 5.4, or the value of the spacing, and you will divide it by the number of dark interference, so destructive interference. So all of the dark lines you will count. We have 1, 2, 3 in this range. So what's it going to be? It's going to be 5.4 divided by 3, which is 1.8 millimeters. We move on to part 2. The experiment is repeated, but this time the slit separation is increased. So what did they increase? They increased d. What's the equation? The equation is y equals m lambda capital D over small d. If they increased d, then y is gonna decrease, and they are gonna get what? They are gonna get closer. So the bright fringes become closer together because the space becomes less. Move on now to question number 4. Two identical loudspeakers P and Q are placed 2 meters apart and emit sound waves in a phase at a frequency of 680 Hertz. Alright, very, very important that we have the frequency in mind. And a microphone is positioned 0.5 meters away from P and 2 meters away from Q, and they told us that the speed of sound is 340 meters per second squared. What if they asked us for the speed of light? Speed of light is 3 times 10 to the power of 8 meters per second. So we have the speed and we have the frequency. Using these two, we will deduce the equation. Lambda is equal to speed over frequency. So it's 340 over 680, which is what? Which is 0.5. So now what did we find? We found the value of lambda, which is what? Which is 0.5 meters. Now, they told us that what type of interference does the microphone detect? How can we know if it's constructive or destructive? Very simply, by finding what? By finding the path difference. Okay, if we find the path difference, we can know if it's either constructive, it will be m lambda, or destructive, it will be m plus half all of it times lambda. So let us see. Let's just take the general equation, which is delta L is equal to m lambda, and substitute. Delta L, how do we find delta L? We have to take the distance of the microphone from speaker 1 and subtract it from the distance of the microphone to speaker 2. So it's gonna be 2.5 minus what? Minus 2 meters, so it's gonna be 0.5 as well, right? So now what's the equation? Delta L equal m lambda. So 0.5 is equal to m, which we need to find, times lambda, which is 0.5 as well, and we get that m is 1. Now, is 1 a multiple of lambda? This is lambda over here. It's 0.5. How do we check? We're going to take m and we will divide it by our lambda, which is 0.5. If we get a whole number, that means it is what? It is a constructive interference. And if we don't get a whole number, that means it's not a constructive. Instead, it's a destructive interference. So here it's 2. That means this is what? This is a constructive interference. Perfect. We move on to question number 5. This question is a mistake. Alright, please keep this in mind when solving. What did they tell us? They told us a monochromatic light beam with this wavelength, 520 times 10 to the power of minus 9 meters. Okay, is directed at a diffraction grating. The slits in the grating are spaced by this. So this is what? This is small d. Okay, they want the first and fourth order maxima are observed on the same side. What's the angular separation between these two spectral lines? Very simply, what does this mean? This means they want you to find theta 1 and subtract it from theta 2. How do we find theta in general? We use the equation d sine theta equals m lambda. So theta equals sine inverse m lambda over d. Perfect. So what does that mean? That means it's gonna be sine inverse m for the fourth one, so m is gonna be 4, times lambda, which is 520 times 10 to the power of minus 9, times what? Times 3.33 times 10 to the power of minus, oh no, this is d, my bad. Should be then over d. So over 3.33 times 10 to the power of minus 6. Now we subtract it from what? From sine inverse 1 times 520 times 10 to the power of minus 9 over 3.33 times 10 to the power of minus 6. So that's basically the same as doing theta 1 minus theta 2 and getting your answer. So let's put it on the calculator. Shift sine 4 times 520 times 10 to the power of minus 9 over 3.33 times 10 to the power of minus 6 minus sine inverse 1 times 520 times 10 to the power of minus 9 over 3.33 times 10 to the power of minus 6. And we will get an approximate answer. It's what? It's 29.7, so approximately 30 degrees. Now, what diffraction order will not appear in the pattern? So when they say will not appear, meaning they're looking for more than the max. In order to get the maximum, we should know that sine theta is going to be equal to 1 or that theta is equal to 90, either or work, in order for us to find the maximum. So what's the equation if we have sine theta and we need to use it in diffraction? The equation is d sine theta equals m lambda. So we need to find the value of m. We already have d, which is 3.33 times 10 to the power of minus 6. Sine theta, we need to find it. Sine theta is 90, sine 90, my bad. Sine 90 is equal to m, which we need to find, times lambda, which is 520 times 10 to the power of minus 9. So then m is going to be equal to what? It's going to be equal to 3.33 times 10 to the power of minus 6 times sine 90 over what? Over 520 times 10 to the power of minus 9. And this will give us an answer of 6.4. What does this mean? This means the nearest whole number before 6.4, which is 6, is what is the maximum number of lines. Anything after, for example, 7 does not exist. Okay, perfect. So for this one, they don't have 7, so I'm just gonna put the highest, which is the 5th order. I will cut my video here. This is October 4. I will cut it off right now and then I'll continue it tomorrow morning. So that's why if you see the timing is long on the quiz, or like the timing is different, this is all because I cut it off, okay? Hello guys, good morning. I'm gonna continue now with the sixth question. A laser light of 650 nanometers, that means 650 times 10 to the power of minus 9 meter, is incident on diffraction grating, the second order, meaning that m is equal to 2, forms an angle of 32.5, so theta is 32.5 with respect to the central maximum. They want d, the distance separating the two neighboring slits. So how do we find d? If we have lambda, if we have m, and if we have theta? Very simply, we use the equation d sine theta equals m lambda. So d is equal to m lambda over sine theta. Put it on the calculator. And you will get an approximate answer of 2.42 times 10 to the power of minus 6 meters. Now, the number of slits per centimeter, notice they want it in centimeter and that they want n in centimeter. So n is equal to 1 meter over 2.42 times 10 to the power of minus 6 what meter. How do we change from meter into centimeter? We very simply need to multiply by 100. So because we have d in what in meters, we will now change it into centimeters by multiplying by 100. Right, so if we put it on the calculator, 1 over 2.42 times 10 to the power of minus 6 times 100, this will give us an approximate answer of 4,133. So this is the number of slits per centimeter. So they don't have the answer. I'm just gonna put 5,000. But the number of slits, I think this is also a mistake, by the way. But the number of slits is what the number of slits is 4,133. Perfect. Also here they don't have the answer as well. We'll move on to question number 7. What does it say in question number 7? Consider an ocean wave traveling normally towards two gaps between two islands. The diagram below is not to scale. The change in direction of propagation of the wave is due to diffraction phenomenon, and the pattern formed by overlapping waves is due to what is due to the interference phenomenon. Now, assume that the amplitude of the wave is 25 centimeter. What do they mean by amplitude? They mean the height of the wave. So this is wave 1, has an amplitude of 25, and this is wave 2, which also has an amplitude of 25. So they want us to find what? They want us to find the amplitude of the wave x, the wave at point x. So what can you see at point x? Very simply, we know that the dark blue areas, they are what? They are crests. And the light blue areas, they are what? They are troughs. So if it's at point x where a crest and a crest meet, so it's like this. You have this wave here and then this wave here. So a crest and a crest meet, both of the same amplitude, 25, they're gonna form what? They're gonna form a bigger crest. Okay, so it's gonna be constructive interference because they're both in the same direction. So it's, which is upwards. So they're gonna be, or maybe it's even downwards, but it doesn't matter. As long as they're in the same direction, it's gonna be constructive interference, and thus this will cause it to be what? 25 centimeters plus 25 centimeters, which will give us a total of what? Which will give us a total of 50 centimeters. Now, for point Y, over here, it's what? It's a crest with a trough. So this is what? Destructive interference. So look, it's like this wave meets with this wave. So a crest and a trough are meeting. This is 25 up, this is 25 down. They're gonna cancel out and we'll get an answer which is what? Which is 0 centimeters. Alright, so this is 50 centimeters and this is 0 centimeters. Let's move on to question number 8. What does it say in question number 8? It says, a physics student sets up a double slit experiment in the lab. The slits are separated by this distance, always change it to meter, so 30 times 10 to the power of minus 6 meter. We also have theta is 6.2 and m is the fourth order. That means m is equal to 4, not 1, 4. So what do they want us to find in the first part? They want the wavelength, lambda, of the laser used. How can we find lambda if we have m and d and theta? We'll very simply use what? We'll very simply use the equation d sine theta equals m lambda. So 30 times 10 to the power of minus 6 times sine 6.2, so theta will replace it by 6.2, is equal to m, which is 4 times lambda. So lambda will be very simply equal to what? And you will round it and you will change it from meters into nanometers, and you will get your answer to be 810 nanometers. Perfect. Now, they want the maximum number of bright fringes that can be observed on both sides. When they say maximum number, this means that sine theta is equal to 1, or that theta is equal to 90. We know what? We know that d is equal to 30 times 10 to the power of minus 6 meters, and what? And we found lambda to be what? And we found lambda to be 810 times 10 to the power of minus 9 meters. Perfect. So they want us to find the maximum number of bright fringes observed on both sides, meaning up and down, and we include the central brightness. So let us solve it. Now it's going to be d sine theta equals m lambda. Now d sine theta is what? Is 90, is equal to m, which we need to find lambda, times 810 times 10 to the power of minus 9. And d is how much? D is 30 times 10 to the power of minus 6 meter times sine 90. So now that means m is equal to what? M is equal to 30 times 10 to the power of minus 6 times sine 90 over 810 times 10 to the power of minus 9. And this will give me an answer of 37. But this is wrong. Why? Because this is only 37 up. There's also what? There's also 37 down as well. So 37 times 2, or 37 plus 37, this will give me an answer of totally being 74. But this is still not our answer. Why? Because with all of this, we do not include the central brightness. So that's going to be plus 1 more brightness, which will thus yield for us 75 bright fringes. So we have 37 up, 37 down, and 1 in the middle. So in total, it will give us an answer of 75 bright fringes. Now we move on to part B. If the experiment was repeated using a light source with a shorter wavelength. So what's our equation? Our equation is d sine theta equals m lambda. So what did they tell us? They told us we used a shorter wavelength. So we decreased lambda. What will happen to theta? Theta will decrease, right? And if theta decreases, what does that mean? This means they will become closer together. So as lambda decreases, theta is going to decrease. Why? Because they are on opposite sides of the equation. They're directly proportional to each other. And when theta decreases, this is the angle between the central axis and a certain point. And if theta decreases, what's going to happen? They will all come closer together. They will become more compact. Okay, so this will lead to what? This will lead to a greater number of total fringes formed. Why? Because as lambda decreases, m is going to increase, because lambda and m are inversely proportional to each other. So as lambda decreases, m decreases. As m decreases, lambda increases. Okay, so to answer any question like this, just write the equation and see which one is directly proportional to which one. All right, so the angle becomes smaller, or it decreases. The maxima and minima move closer together, and they will become more compact, and this will lead to a greater total number of fringes on the screen. Now we move on to question number 9. What does it say in question number 9? Yeah, this is, as I believe, question number 3. No, yeah. It's the same thing as question number 3, just more questions. So again, how would we solve? They gave us that 4 bright fringes have a position of 5.4. So what is the position or the spacing between consecutive bright fringes to one decimal place? Consecutive bright fringes means directly after each other. We know that the total is how much? Is 5.4 divided by what? Divided by the number of dark fringes, because the spacing between consecutive bright fringes is what is considered as the dark fringe. So you take the total spacing and divide it by the total number of dark fringes, which is 3, and thus you will get an answer of what? You will get an answer of 1.8. So this is what? 1.8 millimeter. Now they want us to find what? They want us to find the separation of the slits to one decimal place. What do we have? We have that this over here is what? Is y. This is the spacing between consecutive bright fringes. This is y. We also have what? We also have lambda, which is 600 times 10 to the power of minus 9 meters. And we also have what? We also have capital D. So using all of these, I believe we'll be able to find what? We'll be able to find the value of the separation of the slits, which is small d, knowing that it's consecutive bright fringes, meaning that m is equal to, for example, 2 minus 1, which is what? Which is 1. So now, using all of our given, we'll be able to find the value of d. We know that the equation is y equals m lambda capital D over small d, but now d is our unknown. That means d is equal to m lambda d over y. Now you just need to substitute. M is 1, lambda is 600 times 10 to the power of minus 9, and capital D is what? Is 1.2 divided by y, which is 1.8 times 10 to the power of minus 3. So 1 times 600 times 10 to the power of minus 9 times 1.2 over 1.8 times 10 to the power of minus 3. This will give us 4 times 10 to the power of minus 4 meters. But I noticed that they want it in millimeter. So to change it from meter to millimeter, what do? I will multiply by 10 to the power of 3. So that's going to be what? That's going to be 0.4 millimeter. Perfect. Now, last one. They want the path difference. What's the path difference? They mean delta L between light rays that form the dark fringe X. The dark fringe X is the first dark fringe after the central brightness. So for the dark fringes, always the first dark fringe after the central brightness will have an M of 0. And remember, the equation for the dark fringes is M plus half lambda. So if we have delta L, which we need to find, is equal to 0 plus half lambda, which is 600 nanometers, then delta L is going to be what? It's going to be half of lambda, which is 300 nanometers, very simply. Let us now move on to question number 10. What does it say in question number 10? Okay, in an experiment, a smooth sphere is placed on the path of a laser beam. The shadow that the sphere casts on the wall is examined. A bright dot is visible in the center, so this is our central brightness of the sphere. So this over here is our central brightness. And a number of bright and dark fringes are seen around the shadow. So this is the first one, then the first, let me choose a different color, wait. So this is the first darkness, then the first brightness, then the second darkness, and the second brightness. What did they tell us as well? They told us that the wavelength of the laser light is 640 nanometer, so 640 times 10 to the power of minus 9 meters, okay? They told us that the bright spot in the center, this central brightness, what is it due? When you see light, this is due to constructive interference, right? If you don't see light, if you see dark, this is due to destructive interference, okay? This is due to the light beams that bend, because again, it's what it is. A smooth sphere being placed on the path of a laser beam. So what's going to happen is that the laser beam is going to diffract, right? It will bend around the sphere, right? So It's due to the constructive interference of the light beams that bend around the sphere because of what? Because of the diffraction of light. Question number 2. Which two are the following path differences between the rays that form the dark fringes? We know when we see dark fringes, the equation will become delta L equals m plus half lambda. So how much was lambda? Lambda for us was 640 nanometers. That means delta L is equal to m plus half 640. First of all, let us take any value. For example, 320, 640. And actually, let's try them all, okay? Delta L. Let's first start with 320. If you move this to the other side, it will be what? It will be 320 over 640 is equal to m plus half lambda. What's 320 over 640? It is basically half. That means what? That means the value of m is 0. And this works because for the dark fringe, the first darkness will have a value of m being 0. So this is a possible answer. Now, if it was 640 nanometers, 640 divided by 640 is what? Is 1. And we know that 1, if it's equal to m plus half, then m is going to be equal to what? It's going to be equal to half, which does not make sense. M can never be a fraction. It always needs to be a whole number. Okay? So what does that mean? That means that 1 does not work as what? Does not work as a destructive interference. Or does not work as a path difference for the dark fringes. We move on to 160. 160 divided by 640, this is 1 over 4. 1 over 4 does not work at all. Why? Because if you were to equate these, you make them equal. Yani 1 over 4 is equal to m plus half. That means m will be equal to what? M will be equal to minus 1 over 4. So yeah, m can be negative, but however, it cannot be a fraction. M needs to be a whole number. So this is why that the 160 does not work either. Now, 1280, what do we get? We will get 2. So 2 equal m plus half, right? So m is equal to what? M is equal to 3 over 2. Again, m is a fraction. It can never be a fraction. It always needs to be a whole number. That means this does not work. And then last but not least, 960. So 960 divided by 640, you will get 3 over 2. So 3 over 2 equal m plus half. M is then equal to what? Is equal to 3 over 2 minus 1 over 2. So it's equal to 1. And since m is a whole number, that means it works, and it's a possible answer. So it's a possible path difference. 960 and 320. These two are what are possible path differences. Now, we finished discussing the path differences. Let's move on to the phase differences. Which of the following are possible phase differences? Okay, very simply, in order to understand the value of the phase difference, it's very simply what? It's very simply the ratio of wavelength 1, right, to wavelength 2, okay? So it's actually 640 being wavelength 2, and on top of it, we'll put any random ratio. It's gonna be multiplied by what? It's gonna be multiplied by 2 pi. So what's the definition of phase difference? It is any multiple of lambda over lambda times 2 pi. But we notice a very important keyword, that it's a bright fringes. If it is a bright fringes, that means m can be equal to what? Can be equal to 0, 1, 2, 3, 4, etc., etc. Now, what does m represent? M represents what? Represents the ratio of any chosen number divided by what? Divided by lambda. So the multiple of lambda divided by lambda is equal to what? Is equal to m. So what could we very simply replace the multiple of lambda over 640 by? We can replace it by m. So now we can start our process. 0 times 2 pi, that's gonna be 0. Okay, so this is the first phase difference, that it can be 0. Then for the second phase difference, it's gonna be 1 times 2 pi, which is what? Which is 2 pi. It's not any of our answers, so we don't choose it. For the second one, we substitute m with 2. So 2 times 2 pi, that's 4 pi. Yes, it's one of our answers. Then 3 times 2 pi, 6 pi, not one of our answers. Then 4 times 2 pi, that's going to be 8 pi. Yes, it is one of our answers. And I think that these are all of the possible answers, okay? So again, to find path difference of constructive or bright fringes, it's m times lambda. To find path difference of destructive, it's m plus half times lambda. Now, to find the phase difference, which is delta theta, okay, it's gonna be equal to what? It's gonna be equal to m times 2 pi, okay? And to find what? To find the phase, this is of course for constructive, which is the bright fringes. And to find the phase difference for the destructive, what do you assume it's gonna be? It's gonna be m plus half times 2 pi. Okay, so m, whenever we see m, that means it's a multiple of lambda. It's gonna be constructive. Whenever we see m plus half, meaning it's a multiple of half lambda, it's gonna be considered what? It's gonna be considered destructive interference. Okay, perfect. Now let's move on to question number 11. What does it say? The spreading out of waves after the gap is called diffraction. This is easy. Now, why does the wave spread out so little? As you can see, the wave in the diagram spreads out so little. You can see how small the wavelength is compared to the gap. What is the reason? The reason is because the gap is bigger than the wavelength. And in order to achieve maximal diffraction, the gap needs to be equal to what? Needs to be equal to the wavelength. So this is to achieve what? To achieve maximum diffraction. Okay, so in this scenario, it spreads so little because the gap is much greater than the wavelength of the wave. We'll move on to question number 12. What does it say? An ocean wave traveling normally towards a gap between two islands. The speed of the sea wave is 2.5 meters per second. This is the speed, and they gave us the period. How do you change from the period to frequency? The period is equal to 1 over the frequency. That means the frequency will be equal to what? Will be equal to 1 over the period. So in order for us to find the value of the frequency, it's going to be 1 over 5 seconds, which is what? Which is 0.2. So very simply, they want us now to find the wavelength lambda of the wave. What's it going to be? It's going to be the speed, which is 2.5, over the frequency, which is 0.2. And this is supposed to yield us an answer of 12.5 meters. So very simply, it's here 12.5 meters. Now, which of the following is the possible size of the gap between the islands? As you can see, it's achieving almost maximal diffraction. And we said to achieve that, the size of the gap needs to be equal to what? Needs to be equal to the wavelength. So you choose the closest value to the wavelength, which in this scenario is 15 meters. We move on to question number 13. Question number 13. A student measures the fringe spacing of interference maxima obtained, blah, blah, blah. They told us that the distance to the screen, capital D, is 1.8 meters. Perfect. We go down, they told us that they want the value of the slope of the graph. Sorry, I put the answer by accident. So they want the value of the slope of the graph. How do we find the value of the slope of the graph? You choose one point. For example, this point over here, which is what? Which is 2.5 millimeter. And it is what? It is 700 nanometer. So this is what? This is the rise, 2.5, and this is the run. We can do rise over run. Why? Because it's a straight line passing through the origin. So the rise in our scenario is 2.5 times 10 to the power of minus 3. Of course, it needs to be in meters. Divided by 700 times 10 to the power of minus 9. So put it on the calculator. 2.5 times 10 to the power of minus 3 divided by 700 times 10 to the power of minus 9. And you will get 3571 as an answer. So you'll take the nearest possible value, which is 3570. Now the separation of the slits. They want us to find the value of what? The value of small d. Small d is equal to what? We need to find it. capital D is equal to 1.8 meters. Then what did we choose as y? I prefer to use y and not x. What did we use as y? We chose y to be 2.5 times 10 to the power of minus 3, and we used lambda to be 700 times 10 to the power of minus 9. Okay, so now what do? We use the equation, which is y equals m lambda capital D over small d. M is 1 in this scenario, so we can remove it, and we can swap the places of small d and y, right? So d is equal to lambda d over over y. So lambda in this scenario is 700 times 10 to the power of minus 9 times capital D, which is 1.8, divided by what? Divided by y, which is 2.5 times 10 to the power of minus 3. And this will yield us an answer of course, we have it in meters. You need to change it into micrometers, and this will yield us an answer of 504 micrometers. We move on to part B. What does it say? It says that the setup is immersed into water and the same data is collected. Can water change anything? So water, the only thing that water can do in this scenario is that it refracts, it absorbs, and it scatters light. So water in this scenario will not change lambda. Lambda will stay the same. So if lambda stays the same, what does this mean? This means that the y-intercept will stay the same. It will remain constant, remain unchanged, and the slope will stay the same as well, okay? So it all depends on lambda, and water will refract, absorb, scatter light, but it will never ever change lambda. And due to this fact, we will say that the y-intercept will remain unchanged and the slope will remain unchanged. We move on to question number 14. What does it say? A student measures the fringe spacing of interference maxima x obtained on the screen in a Young's double-slit experiment for the different distances to screen D. They gave us the value of the slit separation, so they gave us the value of small d, which is 750 times 10 to the power of minus 6 meters. So she represented her graph below. Let us see what they told us. So this is the graph below. They want the slope of the graph. Perfect. The slope of the graph is very simply rise over run. So choose any point. For example, this point is perfect. This point is 1.4, 2.5. So you do rise over run. Why? Because it's a straight line passing through the origin. So it's gonna be 1.4 times 10 to the power of minus 3, because it's in millimeters, you changed it to meters, divided by 1.5. So 1.4 times 10 to the power of minus 3 divided by 1.5. This will give us an answer of what? Sorry, not 1.5, 2.5. This will give us an answer of what? This will give us an answer of 5.6 times 10 to the power of minus 4 meters. So if we go down to check, the closest value is what? The closest value is 5.7 times 10 to the minus 4 is going to be the value of the slope. That's the closest possible value. Now we move on to part 2, the wavelength of the light used in the experiment. What do we have? We already have the slit separation. We can take any point to be y and any point to be capital D. Now, what is the wavelength in relation to small d, capital D, and y? It's very simply y equal m lambda capital D over small d. Now, m in this scenario is 1, so it goes bye-bye. And now we need the whole equation to revolve around lambda. So we will change it, right? And the equation will become lambda is equal to y times small d over capital D. So very simply, lambda equals y. We chose the y before to be 1.4 times 10 to the power of minus 3 times small d. What is small d? Small d was 550 times 10 to the power of minus 6 divided by what? Divided by the capital D, which we chose to be 2.5. Now put it on the calculator. What you get as an answer? 1.4 times 10 to the power of minus 3 times 750 times 10 to the power of minus 6 over 2.5. So this will yield us an answer of 4.2 times 10 to the minus 7 meters. Change it, of course, into nanometers, and it will become 420 nanometers. So you will choose the closest possible answer, which is 427 nanometers. Now we go down again. What does it say? It says that a laser light of a greater brightness. Does a greater brightness affect anything? No, it's just a greater intensity. But it's what? It's the same wavelength, and we said that everything depends on the wavelength. If the wavelength is untouched, then what does that mean? That means the y-intercept will remain unchanged and the slope will remain unchanged. We move on now to question number 15. What does it say? It says, which of the following correctly describe the orders of magnitude of each of the parameters? Wavelength is always hundreds of nanometers. Distance to the screen is always what? Is always and the distance to the screen is always what? The distance to the screen is always hundreds of centimeters. The slit separation is hundreds of micrometers, and then the fringe separation is what? Is always a few millimeters. We now move on to question number 16. What did it tell us? Okay, the table below shows the position of the diffraction maxima obtained using a, okay, they gave us the wavelength is how much? Is 500 nanometers. What did they say? They told us only 4 maxima, that means m is equal to 4 is the highest possible value, are seen on each side of the central maximum. Assuming no more than 4 maxima can be formed on the screen, the separation of the slits in this diffraction grating must be between. So, what do they mean by separation of the slits? This means small d. What's the equation that relates small d, m, and lambda? It's very simply d sine theta equals m lambda. And we know that when we're dealing with the maxima, sine theta is gonna be what? It's gonna be 1. So you can just erase it initially, and you're gonna get what you're gonna get. D is equal to m lambda. Now the only thing we need to do is to substitute, but listen, pay attention. They want the possible values for it to be 4 maxima. What we need to know is that when we consider 4 maxima, we must not forget that it can go above, but it can never be 5 maxima. That means we have a minimum value of m being 4 and the maximum unseen value of m being 5. Right? Because everything that's point, for example, 4.75, we will not consider it 5, we'll consider it 4. So this is why we'll consider everything here excluding the 5. That means it will be in between which two values of d? So that means we need to substitute m one time by 4 and m one time by 5, okay? So d is equal to 4 times 500 times 10 to the power of minus 9. That's gonna be 2 micrometers, okay, perfect. And then if we substituted 5 instead, that would be 5 times 500 times 10 to the power of minus 9, so that's gonna be 2.5 micrometer, meaning that it should be in between what? It should be in between 2 meters and 2.5 meters. Perfect. Now we'll move on to the next one. They told us that, yes, it was indeed in between 2 and 2.5. It was what? It was 2.4 micrometers. Now they want the distance to the screen. So what do we have? They gave us here small d, and we have lambda, which is how much? Which is 500 times 10 to the power of minus 9. And we can choose any values from up for the position. For example, if we chose 4, then that means what? That means m is equal to 4. And y is equal to this value over here, which is in what? Which is in centimeters. So how do we find the distance to the screen, capital D? What's the equation? Y equals m lambda capital D over small d. Now we need to change the equation so that it all revolves around capital D. So it's gonna be capital D is equal to y times small d over m lambda. Perfect. So let us substitute to try and find an answer. Capital D is equal to y, which is 18.7 centimeter. We need to change it into meter. It's going to be 18.7 times 10 to the power of minus 2 meter. Right? Times D. What is D? D is 2.4 times 10 to the power of minus 6, because we're changing it from micrometer to meter. So 2.4 times 10 to the power of minus 6. Over what? Over m, which is 4, times lambda, which is 500 times 10 to the power of minus 9. And we will get what? We will get d to be equal to 0.2244 meter, and centimeter, it's 22.44 centimeters. So of course, we're going to choose the closest possible value, which in this scenario is 20 centimeters. We'll now move on to question number 17. What does it say in question number 17? The graph below shows the sign of the angle diffraction of the, second diffraction maxima. That means m is what? M is 2. Okay, of light for different wavelengths. They want us to find the slope of the graph. Again, it's rise over run. You can choose any two values. For example, this point over here, 0.015 and 600. Because it's a straight line passing through the origin, we will do what? We will do rise, which is 0.015. Rise over run, which is what? Which is 0.015 over 600. We'll put it, now we need to change it, my bad. We need to change it into the appropriate values. So 0.015, it stays as it is. However, 600 nanometers, we cannot keep it in nanometers. We need to change it into meters, so times 10 to the power of minus 9. So 0.015 over 600 times 10 to the power of minus 9, we will get 25,000. They want times 10 to the power of 4, so divide this by 10 to the power of 4, and you will get an answer of what? You will get an answer of 2.5 times 10 to the power of 4 meters. This is the slope of the graph. Now, the slit separation and the diffraction grating, they want what? The slit separation, meaning small d. Perfect. How do we find the value of small d? We know that m is equal to 2. We know that sine theta, we chose it to be 0.015. And we also know that lambda is how much? Lambda is 600 times 10 to the power of what? Times 10 to the power of minus 9. So we'll write the equation that correlates all of these. D sine theta equals m lambda. So d equal m lambda over sine theta. So let us try it. So 2 times 600 times 10 to the power of minus 9 over 0.015. And we will get an answer which is 8 times 10 to the power of minus 5 meters. They want it in micrometers. So you will multiply by 10 to the power of 6 and you will get an answer of 80 micrometer. So the correct answer over here is 80 micrometer. We'll now move on to question number 18. What does it say? Oh, this question is very, 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 very important. Please pay attention and please focus. White light is directed at a diffraction grating of slit separation this much. So D is 40 times 10 to the power minus 6 meters. Now the wavelength ranges between these two values, and these are very, very, very important values. The screen is placed away how many centimeter? 40 times 10 to the power of minus 2 meters away from the diffraction grating. Now what do they need from us? They want the shortest distance. Distance is y, between the first and second order spectra on the screen. So they want the distance between the first and second order spectra on the screen. And which distance? The shortest distance. They gave us two wavelengths, 400 and 700. So in my opinion, look what we're gonna do. First thing, we will find y1 when it's 400 and y2. And then when it's 700, we'll also find what? We'll also find y1 and y2. How do we find that? Very simply, we will use the equation y equals m lambda capital D over small d. So for the first one, it's gonna be y is equal to 1 times 400 times 10 to the power of minus 9 times capital D, which is 40 times 10 to the power of minus 2 over what? Over 40 times 10 to the power of minus 6. And this will give us an answer of what? It will give us an answer of 4 millimeters, okay? For the second one, you do the exact same process, but you change, instead of m being 1, it will become 2, and you will get an answer of 8 millimeters. Now, for the 700, you're gonna do the exact same process as you did for the 400, right? So you're gonna do m lambda d over m lambda capital D over small d, where m was 1. But in this scenario, you're gonna change lambda into 700 times 10 to the power of minus 9. So that's gonna be 7 millimeters. And then last but not least, y2, you're gonna substitute m1 into m2. And you will get an answer of what? Of 0.014, which I believe is basically 14 millimeters. Perfect. Now they want the shortest possible difference. How do we find the shortest possible distance? You always take the biggest one, right? And subtract it from the smallest one. Wrong. You don't do this what you need to do in this scenario, you don't do this by the way, what you need to do in this scenario is to see, okay, which two numbers are the closest to each other. 4 and 8, they're not as close as 8 and 7. 14 and 7, 14 and 4, 14 and 8, no. So the closest two values are what are 8 millimeters and 7 millimeters. Now, what do? We will subtract them. So y2 minus y1, that's gonna be 8 minus 7, which is what? Which is very simply 1 millimeter. Perfect. So the answer over here is what is 1 millimeter. We move on to part B. The shortest distance between the second and third order spectrum. So again, they want the shortest distance, the shortest y between now m being 2 and m being 3. So let us do it again. We need to find when m is 2 and when m is 3. We already have for 400 when y is 2, right? When y was 2 for 400, the value was 8 millimeters. And for 700, when y was 2, the value was 14 millimeters. Now let us find the value when y is 3. So again, we need to apply the equation, which is y is equal to m lambda capital D over small d. So y is equal to m, which is 3, times lambda, which is 400 times 10 to the power of minus 9, times capital D, which is 40 times 10 to the power of minus 2, divided by small d, which is 40 times 10 to the power of minus 6. And this will give us an answer of 12 millimeters. Now, for y3, you're just going to substitute what? For 700 y3, you're going to substitute the value of the wavelength by 700 times 10 to the power of minus 9, and you will get 21 millimeters. Now, what do we do in this scenario? We don't take the biggest and subtract it from the smallest. No, we take the closest two values to each other, which are 12 millimeter and 14 millimeter. Subtract, you will get an answer of 2 millimeter, which is what? Which is greater than 1 millimeter. So it is greater than the value found in part A. Question number 19. If the light corresponds to electric and magnetic field vibrating perpendicularly to each other, yes, they are vibrating perpendicularly to each other. It's going up like this. This is the electric field. The magnetic field is perpendicular to it. I don't know if you can understand from my drawing. Just let me open a diagram. Here we go. Here is a perfect example. As you can see, the electric field is moving up like this, and the magnetic field is moving perpendicular to it, and they're moving all in what? In one singular direction. Okay, so this is the light waves. This is what they're telling us, and it's moving what? It's moving along a single direction. Our keyword here is what? A single direction. If it's moving along a singular direction, then we can say that the light is what? Is linearly polarized, because the light will be moving in a single line. That's why linearly, and polarized because a single direction. Part B, if light corresponds to electric field vibrating in random indifferent motion perpendicular to the direction of propagation of the wave. So because it's random, we will say that it's unpolarized light. Okay, and the process of transforming unpolarized light into polarized light is known as polarization. I think this is a mistake. It's not supposed to be in this quiz, but that's fine. Now, question number 20. An unpolarized light of intensity 20 milliwatts is incident on a system of 4 polarizers whose angles of polarization according to a fixed axis are blah blah blah. What's the intensity of light passing through each polarizer? Because it was unpolarized light and it's 20 milliwatts, it passes through the first polarizer. No matter the angle of the polarizer, it's still gonna be what? It's still gonna be halved. So in this scenario, the angle of the polarizer is what? Is 0 degrees, but because it's unpolarized light passing through a polarizer directly, we're gonna halve the intensity, which is what? Which is 10, which is gonna be 10 milliwatts. So it's directly what? It's directly I0 over 2. Now we can proceed with the equations that we know. So from 0 to 30 degrees, what's the value of theta? Theta is gonna be 30 degrees, okay? So if we wanna find the intensity at 30 degrees, it's gonna be I1 times cosine squared theta. So in this scenario, it's gonna be 10 times cosine 30 squared, which will give me an answer of 7.5. Now, if we move from 30 degrees to 60 degrees, what's the value of theta? It's also going to be 30 degrees. So what's going to happen now? we're gonna find I3. I3 is what? It's I2 times cosine squared theta. So I2 was 7.5 times cosine 30 squared. Put it on the calculator, you'll get an approximate answer of 5.6. And then finally, last but not least, when we move from 60 degrees to 90 degrees, the value of theta is 30 degrees, right? So in order for us to find the value of the intensity, what are we gonna do? It's gonna be I3 times cosine squared theta, right? Is gonna be equal to I4. So I3, which is the previous I, which is 5.6 times cosine 30 squared, will give us an answer, which is what? Which is approximately 4.2. So it's gonna be 10, 7.5, 5.6, and 4.2. Let us submit, and hopefully there are no mistakes. I think, yeah, the only mistake is this one because it's a wrong question. So the mistake is from the quiz itself, right? Because this is, we remember it's 4,133, I believe, slits, and they don't have this approximate value. So just take the one above it. And this one is not choose, for sure it's not choose, but it's a mistake from the quiz itself. So let us submit. And very simply, this is the end of the quiz. Thank you guys for watching. I'm really, really sorry for posting late. But anyways, have a wonderful day, and I hope you enjoyed.